Hello guys, how are you? ¿Cómo están? Eh, this is another problem that in my opinion is kind of out of place, but anyway, the concept is very beautiful. I mean, it talk about first statistics, 85% of neck injuries caused by rear car happens in this way, and then the problem is telling you that this is the plot of the function that happens there, and determine the equivalent resultant force and its location measured from the point A coming from this type of distribution here. This is beautiful. Now, basically, before doing this problem, you have to know resultant force. And resultant force, in terms of, as I said before in the other videos, is kind of the area, right? So if it's kind of the area, the resultant force is going to be the integral of the function in terms of x between the limits that you have over there. And the location, which is coming from the moment equation, by the way, is just basically the integral of x wx dx divided by the integral of wx dx. That's basically what it is. But you should know this beforehand, of course. So now let's say that the problem is telling you the equations, and the only thing that you have to do is solve for those integrals that you have over there. Nothing else. Now you have this inclined like that. Look what happened when you put it in this direction. Everything is perfect. You have x, you have w, and then you can say that your resultant force is the integral of the function. What is the function? The function is this one, 12 times 1 plus 2x squared dx between 0 and 0 0.5. 0 and 0 0.5. And that will be the resultant force. I am not here to teach you how to do integrals. You're supposed to know how to do integrals. So let's say that you solve the integrals your professor allows you, like I do, for example, to solve the integral with this calculator. So the thing that you have to do, you have to come here to the function. You see the integral function here, second. And now you have that situation. You know you are used to find the shape for the integrals and everything. But if you have that situation, let me show you how to use the integrals as a function like that. The first thing that you put in that syntax is the equation 12 times 1 plus 2 times the variable here, x squared. That's the first thing that you put, the function. Then you put comma. The comma is right there. Then you put the variable. What is the variable? The variable is x. And then you put comma again. And then you put the limits 0, comma, and 0 0.5. And close parentheses. And then you get the result here, 7. 7 what? 7 pounds. That's the result that you are looking for regarding resultant force. Now, if you are in an exam and this happens to you and you don't know how to use that, don't freak out. Remember, your calculator has mode. So you go to mode and you keep going down until you find classic or math print. Select math print. And now you can go and select integral again. And this is what you're used to. You see, from 0, you go up 2.5. You come here, and then you put the values that you have. 12 parentheses 1 plus 2x squared and close parentheses and hit enter, and then you get the same value, 7. Okay, now the second part comes from the equation, this equation that we have here. So it's the same basically, but now I have to say that the x bar is going to be equal to the integral of x multiplied by the function between 0 and 0.5 divided by this, but this is just what we did, 7. So the location for that will be just doing this again. So I can use the same formulation that I had here before, and I just have to go high, enter, and introduce this x here. Is the only thing that changes in that equation. Insert, and then I put the variable x times that. I hit enter, and then I get that value. And that value is the numerator. So it's going to be 1.875 divided by 7. And the result for the location should be then 0.2679 feet. What does that mean? That means that for this distribution that you have here, basically, you're going to have a resultant force almost at the center, a little bit passing the center, right there, of 7 pounds, and this distance from here to here will be that distance that we found. This is a very easy problem that looks very complicated, but in reality it's very easy. Thank you for watching, guys, and keep learning. Have a good day.